Hi, this is a video recap for day 2, lesson 2 of our modeling tsunami plate motion engineering internship. So remember, you will be designing a warning system to help people evacuate in the event of a tsunami. A tsunami, we'll remember, is a large ocean wave caused by a sudden shift in the sea floor. Next, we'll watch a video showing 2 different visualizations of a tsunami in the Indian Ocean. Notice that both views show Sri Lanka, the area for your warning system. So this is the first view, and it does not have audio. Okay, tsunamis can travel far across the ocean. People may be at risk of being hit by a tsunami even if they are too far away to feel the earthquake that started it. So warning systems are important. This video does have audio.
Earthquakes are caused by the movement of the huge tectonic plates that continents sit on. What happens is they come together, and one, in this case, the Pacific plate, is moving below the Japanese or Eurasian plate. Now it causes that plate to bend when it sticks there. There'll be a bit too much friction, it'll stick, pressure builds up until suddenly it's released and flick. Have a look at this. Now this is the tectonic plate that Japan is sat on. And here's the Pacific plate coming down underneath it. And normally they want to move together at about 9 centimeters a year. But sometimes they get stuck. When they get stuck, the energy of them moving together gets translated to strain energy, literally flex and bend in these huge slabs of rock. And that energy builds and builds, and flexing and bending more and more. When they finally slip, that stored energy, all that twist and bend in the rock gets released into sudden movement. Like that. As you can see, it literally flicks up, moving the ocean floor above it, which moves the ocean, causing a tsunami. So here we've got a bigger submarine version of what's going on. This gives a representation of what's been happening 24 kilometers below the ocean surface in the Japan Trench. And these things work in what they call a stick-slip way. Most of the time they're stuck, but occasionally they slip. And that's what an earthquake is. So we've got it here, this is bent up here, full of pent-up energy, waiting to slip. And when the slip happens, that energy gets released into the ocean, causing a series of tsunami waves, moving in both directions across the Pacific.
Okay, so what did you observe as you watched the videos? Hopefully we saw that the waves moved quite a far distance. We also saw how the sea floor plays a role in a tsunami. So here we look at this diagram and discuss what we discovered when you modeled tsunami waves. So in that video, we saw that before the earthquake, as that gentleman had in his video, he had the 2 wooden blocks pushed together, and when they did finally slip, it caused a huge upwelling of water. And now that's going to go in both directions. So the plate motion is going to snap up and this plate is going to snap over, which is going to cause this water to go up and then travel in both directions. Okay, so these are some questions that you can think about as you go ahead and do today's assignment. Throughout your internship, you'll be using the Futura workspace to access our sim for this unit. So in order to use it, you're going to test sensors for your warning systems. You'll use a digital model called Tsunami Alert. This model predicts the locations of earthquakes and tsunamis. Engineers use models like Tsunami Alert to predict what will happen. They can change variables and see what outcomes happen as a result. So press the button at the top right corner of the Futura workspace to open the Tsunami Alert. You're going to explore Tsunami Alert. As you explore, think about ways the model is accurate and ways it is simplified. If we were in class, we would discuss this, but since this is a video recap, we can say that the model is accurate because the map, the countries, the geographic locations are accurate, but simplified, we do have some aspects of the wave that's created are being simplified. Tsunami Alert is accurate in many ways. The map of the Indian Ocean and locations and magnitude of earthquakes are based partly on historical data. But like any model, Tsunami Alert is simplified and accurate in some ways. And that is the end of day 2 of our lesson. So with that said, you are going to go on to the Google Doc attached to today's post, and you're going to answer that. In the Google Doc attached to today's post, there is a link, and it will ask you to request access to the document. Just use the link that I posted in the comments below. So don't try and open that link there because it won't take you to where you need to be. So go ahead, and on today's post, I made a class comment with the actual link. If you have any questions, don't hesitate to reach out.